Okay, number 4 is a simple stoichiometry problem. In the reaction, 2-RbNO3 yields 2-RbNO2 plus O2, which is, this is rubidium nitrate yielding rubidium nitrite and oxygen gas. How many moles of oxygen are produced when 5 moles of rubidium nitrate decompose? Alright, so we've got 5 moles of RbNO3, rubidium nitrate, and we are trying to figure out how many moles of oxygen we can actually make. So, our given, we have 5.0 moles of RbNO3. We are looking for how many, not grams, so used to doing grams, how many moles of oxygen we're trying to make. So this is a very simple problem. To go from moles of our first substance into moles of our second substance, all we have to do is use the mole-to-mole ratio, which is our coefficients. So we've got 2 moles of rubidium nitrate for every 1 mole of oxygen, and it's 1 because there's no number in front of that in the balanced chemical equation. So we just write that as our equivalent statement. 2 moles of RbNO3 equals 1 mole of O2. So remember, all we're trying to do is go from moles of rubidium nitrate into moles of O2. This is just a one-step conversion. We've got one arrow here. This is our one equivalent statement that we need. So we are already ready to do our equation. We started with moles of rubidium nitrate, RbNO3, and we are trying to go to moles of oxygen, which means that we need moles of rubidium nitrate on bottom to cancel our units out. So moles of rubidium, that gets us into moles of oxygen. So at this point we can just do our substitute and solve. Plug our numbers in. We're given 5.0 moles of rubidium nitrate. Okay, and then remember we use our coefficients here. It's 1 mole of oxygen, 2 moles of rubidium nitrate. So this is going to be 1 on top and 2 on bottom. So 1 mole of oxygen for every 2 moles of rubidium nitrate. So really all we're doing is taking our 5.0 and dividing it by 2. So that's 2.5, and then we just need to do our significant digits. We've got 2 here. Remember, mole-to-mole ratios are always exact. So this has 2 significant figures, so our final answer is 2.5 moles of O2. Okay, number 5 is the exact same type of problem. It's just a different scenario. So in this one, we've got 2 hydrogens and 1 oxygen yielding 2 waters, and it asks how many moles of oxygen are there required to fully react with 6 moles of hydrogen. So same type of thing. We're trying to go from moles of hydrogen, remember that's diatomic, to moles of oxygen, also a diatomic. So this is a one-step conversion. We are given the 6.0 moles of hydrogen. We're trying to figure out how many moles, sorry I keep writing grams, moles of oxygen that would be needed to fully react. So we just need to do our equivalent statement. That's using our coefficients. So there's a 2 in front of the hydrogen. There's nothing in front of the oxygen, which means it's 1. So this is a 2-to-1 ratio. 2 moles of hydrogen for every 1 mole of oxygen. So now we just need to do our equation. We started with moles of hydrogen. We're trying to get into moles of oxygen. which means we need moles of hydrogen on bottom so that our units cancel. Substituting into this, we're given 6.0 moles of hydrogen in the problem right up here. So that goes down here. And then this moles of oxygen and moles of hydrogen, that's just this equivalent statement here. So that means 1 mole is going to go on top and 2 moles of hydrogen on the bottom. 1 mole of oxygen, 2 moles of hydrogen. So really all we're doing is taking a 6.0 and dividing it by 2, which gives us 3 on the calculator, if you need to do that in the calculator. And then we need to do our significant digits for this. This has 2, these are exact, which means that we need to make this number have 2 significant digits. Right now this only has 1, just the 3. So to get this to have 2 significant digits, we just need to add a 0 after the decimal, so 3.0 moles of O2 is our final answer. Alright, and number 6. Calcium hydroxide, hydrochloric acid react to form calcium chloride and water as shown in the chemical reaction. If the chemicals are present in exactly the correct ratios to fully use all the ingredients, how many moles of water would be formed from 5 moles of hydrochloric acid? Alright, well in this situation we're given the reaction, but notice there's these blanks here, so we actually have to balance this equation before we can do the conversions. So we've got calcium, and we've got oxygen, and we've got hydrogen, and we have chlorine. We have 1 calcium on our reactant side and only 1 calcium on the product side. We have 2 oxygens because this 2 goes with everything inside the parentheses. 2 oxygens on the reactant side and then only 1 oxygen on the product side. And the hydrogens are a little bit trickier because we have a hydrogen here and we also have hydrogen here in this other compound. There's actually 2 here because remember this 2 goes with everything. So the way we write this is we say 2 plus 1. Okay. And then on the other side, we only have 2 hydrogens. I apologize, this is supposed to be subscripted, and unfortunately I skipped this one when I was going through and putting everything in correct formatting. So that should be a 2 as well. And then the last thing is our chlorines. We have 1 chlorine here, and we have a subscript of 2, which means we have 2 chlorines on our product. So 1 and 2. Then we go ahead and start balancing. Our chlorines aren't balanced, so we need 2 more on the reactant side, which means we put a 2 in front. Well, there's also hydrogen as part of this compound, hydrochloric acid, which means that we need to multiply our hydrogen, our single hydrogen, because there was only 1 hydrogen in this compound to begin with, by 2 as well. Okay, and then we can keep going. So we balanced our chlorines, and the next thing to do is our oxygens. So we have 2 oxygens on our reactant side, and we only have 1 on the product side. So we'll multiply our product side by 2, which means we have to put a coefficient in front up here, okay, which means that everything in this compound gets multiplied by 2, which means that these hydrogens also get multiplied by 2. So now we have 4 hydrogens on the product side. If we look and reassess, our calciums are balanced, our oxygens are balanced now, our chlorines are balanced. We just need to check our hydrogen, which is a little bit more complicated. So we have 2 times 2, which is 4 hydrogens on the product side. And then we have 2 plus 1 times 2. 1 times 2 is 2. So 2 plus 2, this also equals 4. So this equation is now balanced. Okay, just so that I have room, I'm going to go ahead and erase this stuff here. Okay, just so that we have more room to do this problem now. So in this problem, if we look, we are given 5 moles of hydrochloric acid, and it says how many moles of water would be formed. So we know that we have 5 moles of HCl, hydrochloric acid. We know that we're looking for the moles of water, H2O. All right. So if we go to our mole map, that means that we're going from moles of hydrochloric acid into moles of water. This is a single step. Okay, so our equivalent statement is using our coefficient, so we just have to look. There's 2 moles of hydrochloric acid for every 2 moles of water. So 2 moles of HCl equals 2 moles of H2O. Okay, so now we just do our equation. We were given moles of hydrochloric acid. We're trying to go to moles of water. And we need to cancel out our units of hydrochloric acid, so that goes on bottom. And then we just substitute and solve. We have 5 moles of hydrochloric acid. Our mole to mole ratio is 2 moles of water and 2 moles of hydrochloric acid. So then if we go to do this, that's 5 times 2 divided by 2. So really those cancel out. 5 times 2 divided by 2 is just 5. So we have 5 moles of water. And last thing is to look at our significant digits here. So if we look here, 5 only has 1 significant digit. And remember, our mole to mole ratios are exact, which means we need our answer to have 1. So this is the final answer for this problem.